Okay, let's start. This is our TACC Training 3. This is our last section. Today, I'm going to separate into 4 smaller topics. The first one is interactive development environment. The second is MPI, that is for the parallel computing program. Third one is a script. Whenever you want to submit a job, you have to write this script. We have the template. You can copy into your home directory, make a simple modification, and then you can use in the future. The last one, the first topic is regarding the management. How to you manage your job, to monitor it, to kill it, to control it. Okay. Before we jump into our topic, I want to let you know one thing. Last time I mentioned, when you see my video, you will see a section I show you in the .local directory, the file system over there. That one is actually, when you follow the video, you probably does not see that directory because that directory was created by the command install the Jupyter notebook, because I already installed myself. So I show you what is the directory structure, bin directory. But actually, if you follow the video, the .local directory is not created yet. Only after you install the Jupyter notebook, that directory is going to show. Okay, so I need to make clear in case you are confused for the video. Okay, let's get into our first topic, interactive development. This is the documentation. IDEV. IDEV is a command, submit a batch job. The supercomputer is designed for you to submit the job and then the job to distribute it hundreds of the computing nodes to run your program in the back end. Are not designed for write your code, debugging your code. That kind of job supposedly you already done. But if you only have a smaller program you want to debug on-site in the supercomputer, they have a special environment that is called interactive development environment. The command is called IDEV. This environment is actually still a batch submission. When you see this IDEV environment, you will see it's actually they are submit a batch, and they also, why they stop there to waiting for your interactive is actually the program in the sleep mode, and then you can type command to interact with this environment. Okay, this is something we probably time to time we want to use it. Before we log in, give you the brief definition here. IDEV is a utility created for interactive development environment for the user's login window. User connect directly to a computing node. When you run this command, you really don't know which computing nodes you actually landed on. Every time you probably landed on the different computing nodes. This one is going to be a single node. They don't want you to allocate one computer for a long time. So they only give you 30 minutes. After 30 minutes, they probably kick you out. So this is only for your program has error or you want to interact it for a short period of time. But for our beginners, we already get used for develop something on the computer. So this is maybe you want to use. For our training purpose, we also use that one to interact. It's a prompt you for the project name, and then save your selection as a default interact count. This is hiding file in your home directory. That's going to be save your project name. Project name is they use for how to charge your hours. Okay, this is the example I'm going to show you at here. So let's log in. Let's log in. Code. That's my slides. Let me make this bigger. Okay, you see here we are in the home directory. Everyone log in? Okay. Home directory is only for you to save your file. The home directory login nodes, they does not design for you to run the program. So never run your program in the login nodes. If you want to debug your program, we are going to use IDEV. Type in IDEV, IDEV, and then hit enter. In the background, they actually submit a job to waiting for the system sign you in a particular computing nodes. So that is why you need to waiting for a second after you submit your job and request for the interactive development environment. You see here, verify access to designed queue. Designed queue. The queue means the partition, means the architecture. They had special development environment in the SKX, that is Skylake. They use that kind of the computing nodes. And then they verify. You see here, since we only have one project, they are going to pull out our default project ID, verify our project ID to count our hours, and then they calculate quota. This is our home directory. It's a SCABI3. This is our job ID. You see, this is exactly like a same batch job submitted. And then the master node, they going to put your job, find available resources, status pending, PD is pending. And then waiting seconds, they change to the job status to R, is running. You see here, this is the one to tell you the particular computing nodes. The architecture is SKX. This is computing nodes number. Did you get the same computer nodes or different numbers this here? I'm in the 104. How do we know this is actually batch job? We can type SQEUE -- me to check my job status. You see here, user is my name and running status, node ID, what time they started. Let me start a new terminal. Okay, this one is look better. Yeah. Token code. IDEV. Let's see, the next slide is if you want to find more detailed options for the IDEV, they can have the dash help, and then you can exit the interactive directory, the environment, Control D, and this is a command to launch interactive batch is ID wrong to send launch MPI application. The default is actually dash capital N means how many nodes. Is the default, I think, is 1. Every time interactive environment, you land in one node. Each node has 48 cores. So that is the default. Number of the nodes, number of the process. Okay. This is just let you know how to get into interactive sessions. And here you can run your program to add the output into the console, so you can see what is the result and how do you debug your program. Okay, the next topic we are going to have example MPI programming. You probably does not really need this one, but anyway, if you want to run program parallel, you need to know this program. Okay, so we Control D to exit our interactive environment, get back our home directory. Since we are going to do a one smaller exercise, I already create a Hello World program. It's in my work directory. At the same time, let's practice how do you copy file from, right now I'm in the home, okay? I'm in the home, pwd, you will see it's a home one and then code your username. If we get into the work directory, everyone has 1 terabyte. Most of the case, if you want to install something, you're going to put into your work directory. And if you want to upload your data, image, probably you want to use this 1 terabyte space. Let's cd environment variable $work work. Okay, you see we still in the login nodes, but we change to your work directory. You will see if you cd $work, and then your directory going to change to work2, the code and your username. Currently log into Stevie3, so this is your work directory. Let's see, at this time, if I listed my file, I have all these 1 file, 1 directory. Let's go 1 level up our directory, cd space *, and then pwd, I'm in the work2, that code, my name, and listed file. You see here, last time we already mentioned this one, the Stevie3 and also Lone Star 6, the working directory is in the same place. I create this llama shared. If I ls-al, you will see I create this one. I gave our group read write execution. This is our group ID to check if you are in the same group. That is a Unix work group G826615. Everyone check. Just the list. Just the list. Space -al anywhere. Are you in the same Unix group? This is your username. This is Unix group. Anyone? Do you have the same Unix group with me? Okay, that is when they design system, they based on the project. Every project going to be a same Unix group. In that way, in our project, we can share the file. So you are in the, make sure you are in the work directory. So let's make sure, type cd $work. cd $work. This is the environment variable. And then wherever you type this one, you are going to be in your home directory. Did you get the logic? You see, in my home directory is under my name and the Stevie3, but I create a llama shared folder outside of the Stevie3. You see here, I create this folder is outside of Stevie3. I can share this shared directory no matter you log into Lone Star 6 or Stevie3. So you can access because I gave everyone access privilege for this directory. Okay, let's try. So you are in work directory, and then let's copy this command. Let's copy this command. Copy space -r means recursively. I want to copy a directory and everything in that directory. Space, I want to give a full name. Since here you cannot use the environment variable because your environment variable is yours. You want to copy file from my shared directory. So you have to give, but you always can use the tab there, 09973 tab. And then my user, if I type some and then tab, they automatically, and Lamar tab is automatically complete. Lamar shared exercise 1 space. I want you copy a folder from my shared directory to your work directory and copy everything within that exercise 1 directory and give a $work/dot. Means recursively copy a folder x1 which is in the Llama shared directory underneath Frank Fang's work folder into your workspace and copy underneath your workspace. Try it if that works. Okay, you got it? Okay, let's VI to look at hello.cpp. This is the C++ file, the MPI file. You see including MPI. Basically, this one is a C++ program, and then they are going to type hello world and initiate MPI, and then type hello world, output hello world to the standard output, and then finalize. It's just a very simple hello world program. And then you see here, we want to module. Let's check the module first. Last time we saved the Python into your default module. So when you module list, you will see the Python, but here you do not see the C++. And for this program, we are going to load GCC. You put the slash and then tab. Tab is going to automatically, we are going to load GCC compiler, and then we check the module list. You will see the GCC is loaded. So we have GCC compiler available. So this is something supercomputer, you need to load the module to get your environment, since there are multiple versions of the software compiler is available. And then this is a command. We are not going to use the normal GCC. When you use CS server for the GCC, we are using MPI GCC, that is compile parallel computing. So MPI CXX. So we had source code, hello CPP, and we want -O means we want output the executable called hello. So hello.cpp, that is the source code. Previously, you see here, this is the source code. We want to compile it into a executable binary code, and then we give a name. If you does not give the -O name, and then they are going to automatically generate a.out. Okay, that is the same. So we compile this one. Which MPI? So module load.
You don't have IMPI.
MPI.
IMPI.
IMPI. Okay, let me try. Okay. Somehow I'm missing a one. Okay, we already compiled, and then we submit. Submit. You see here, we have this submit script. Let's look at it. VI submit MPI. It's just this is our submission. They are going to use the bash environment, USR bin environment bash, pound side. One pound side is actually this script going to use it. It's not like a normal Unix script. You put pound side means you come out. But here it's very strange. Pound side, they actually use it. If you put two pound side, you come out. Okay, so that is something special. Basically, they tell you my script going to use one computing nodes, and then I'm going to use 48 cores. One node, 48 cores. Here, each CPU has 24 cores, two CPU, 40. And then I'm going to use interactive environment to run my current directory, hello, that binary executable. Okay. You see, right now we are in the login nodes. Whenever you're in the login nodes, you can submit a job. Submit job is going to submit this script. The master node has a scheduler to find which architecture, which queue you are going to use, which partition you are going to use. So you can submit job in the login node, but you cannot directly run your program in the login node. Here, sometimes it's confused. And what we actually doing here, can you see this one clearly? Let me put bigger. This is the way we submit a job. As batch, submit a batch file. -A is our project code. This one, CDA, that is our project code. That is our Lamar. And I want all the output right into a log file. I gave that log file name called output.log. You will not see anything from the screen. You will see they are going to write into the log file. And then I want to use the partition, PVC as partition, and also the time I allocate my job to means 2 hours. This one is just seconds, but you can define how long. The supercomputer, they has time limitation. Probably the maximum is 48 hours. And then the script is in my current directory, /. The script name is called submit MPI. Okay. We are going to type batch A. You have to remember our project, so they are going to count our hours. Put.log and partition PVC. Partition, we already talked the architecture. We can use ASCII X or different. Let's see what's the rest of here. Time to hour from current directory, my submit script file, MPI, shell. Let's try. Coda not currently enabled file. That is okay. Verify Coda, and this is okay. You see, they have the job ID. We can look at our --me to look at if my job is. You see, if you quick enough, you will see your job. It's in the queue. Status. This is a status. If you see, I think it's already done. CG is a complete, clear and complete. If I run, it's gone. You see, you do not see anything in the output. Where the output is, the output is in the output.log. You see, hello world, they are going to run total 48 threads. One node, 48 cores simultaneously run parallel. This is a parallel computing. Okay, they tell you, okay, it's shut down, complete, and exit. You will see total. You see, this number is not sequential. Yeah, some core is faster and some core is slower. It's not, but total 48 is going to process hello world. So one line of the code type hello world, they are going to parallel give you 48. Okay, this is the example of the batch. Okay, I exit. So then you can run interactively. Most of the case, we don't want to run interactively. That's thousands of the nodes, and then especially interactive only give you half hour. You never can finish your real job. But this is just for the testing purpose. I write example here. I'm not going to run this one in here. Let's continue. The key is how do you write your script? Okay, we want to know the options. Here I have examples here. This one I copied from the documentation. This documentation is come from here, JavaScript. Step 3, JavaScript. So here you can maximum running time -t. We already tried that one. You can specify number of the nodes, capital N, and total number of the MPI task is a smaller n, and then your project. You need always have the project name. Otherwise, they don't allow you to run. That is -a. You can copy this script. You see, if you're running SPR, that partition, you can run different kind of the job. This is the example. Here, they give you explanation, and then this is the example code. And here, you give your job name, capital J, and output into here. If you have the error, you want to write into another output file. Partition gave a special architecture. The previous example, we use PVC. And how many nodes you want, how many MPI tasks, and how long the time. You can set up your mail. Whenever the job finish, they directly send your email. So you do not need to worry about something. You have always to check what the status. Here is a list. Okay, this is example. I actually has, you see here, this is the one, VI, SPR, I basically copied the documentation into here to create our file. So you do not need to retype in all this. You just copy this one into your home directory and modify later on. I already did something. For example, here you change your job name, and you can change output, what the output. You can change your architecture partition, and you can change mail. For example, you can put your email here. They directly send you email to tell you what is the status. You see here, I already put into our project ID here. In that way, you does not need worry about anything. This example, I want to show you how to use Scratch. Previously, this example, we run our project in our work directory. If you really had a huge data set, several terabytes of the image, you do not space it into work directory, you can copy into Scratch. Actually, they recommend you run your job in the Scratch at huge space. And Scratch is a high-speed connection. Let's see what is our example here. Okay, let's do this exercise. Okay, we already know we have PWD. Right now, I'm in my work directory. So make sure type CDW, and you list it. You see you have X1, that folder which you already copied. You CD X1, get into that X1 folder. We want to copy hello, that is binary. You already compiled. And then you want to copy it into your Scratch. Oh, here I cannot use tab to finish, so I have to type SCRATCH. Okay, I copy my binary code into my Scratch. Since Scratch, they are going to purge anytime. You cannot permanently save all there. So you compile into your work directory when you really want to run and a lot of data access and have the big data space, you want to use the Scratch. This is the way how to use Scratch. So I copy my hello into my Scratch. So you see, I'm in my work directory. I want to copy my hello binary into Scratch. And here, also you want to copy the SPR that script file into Scratch. Sorry, I'm missing the destination, Scratch. Okay, I copy these two files into my Scratch, and then I want to get into the Scratch. CD dollar Scratch. I jump into the Scratch. Let's PWD. You see here is a different location. It's a Scratch, the code and your user. So in the Scratch, oh, you see, I actually let's see. That is August 19th. Today is 25th. You see, they still keep around 1 week. But don't rely on this. They can purge anytime, but you see, they give you several days. Here, this is the space, no limitation. You can really have a huge file that's not really. So we are in the Scratch. Let's VI our script file. Okay, you modify your email address, and also you modify the job name. You give your name and give your email address. ID is over there. Since I already have my job. Let me change some job. I gave another name. I gave my name. This is my job name. This is output file. It's going to be here. If something happens error, they write into this .e. And we are going to use that partition. 4 nodes, 448. Previously, we run only 1 node, 48. This is 448. I gave 1.5 hour runtime. I gave my email address and mail all type means wherever finish, error, anything happens, send me an email. So I can dynamically monitor my job. Basically, they are going to run module list to write that one into your output file so you know what kind of environment you are running for this one, and to tell PWD which directory you run from, and also give the date and the time when you run this job. Okay, and then you want to save it, hit the escape key and the shift colon WQ command. Okay, it's WQ. Colon WQ explanation mark. Okay, let's see what the file here. Colon W, smaller W, smaller Q, and explanation mark. You are going to save. So make sure you change your name, give the email address. You do not need to modify anything. In the real situation, you just need to modify this one line. Whatever you have a Python program, you see this is a script, is template. You just change one line. If you run MATLAB, you just go ahead to change this one line, which executable you want to run. And then I exit. This one I do not need to write. And then change your email address, program name, and then here. This time, you do not need to write a partition. You do not need to write how long the time. You do not need to write what the output. Since you already including in the script, you directly use as batch. Submit this batch file. You see, allocation is okay. Verify quota is okay. This is your job ID. So you can monitor your SQEUE and space -- me to look at CG. That means I already finished. You see, I already finished. That is strange. I expect it's going to take a long time. You see the output here. How long it takes? 25, 1. Let me look at it. Some job. I want to look at my output. Hello world. You see here, I suppose running 448. Do I have to 448? 200 process hello world from 140 hello world of the shutdown complete. Do I have an error? Why is the 223 is complete? Let me look at it, my error. Some error does not have error. You see, I kept my error file. This is a job list, module list. It is listed correctly. Actually, I'm expected going to take a little bit more time. Let's rerun this one again to look at what's happened. SQ-me complete -me not complete. Oh, here it's gone. Let's see 112. This is a 1. You see, This is the job ID. Even the name's same, the job ID, the different job, different time. This is a 112. I want to look at it. This one looks okay. You see, they totally 448. That is something strange. Probably you need to really modify your. I don't know if they already sent me email or not. More is another command to look at your pipe into more. So in that way, you can page by page. CAT is going to view your documentation at once. This is our fourth, the last topic, how to manage your job. There are several commands, for example, as info. But anyway, you can play around. I'm going to continue for my lecture here. This is the one command to monitor your as info. That is going to list it everyone. I don't want to as info dash help job management. Okay, previously you see CG means complete, R running, PD is pending. I want to see that info here. A is allocated, I is idle, offline, total. So you can use this command to see how many nodes is idle. As far as has more idle, you want to use that queue. You see the different partition. They have the different number of the idle of the nodes. You see this one is 70. Okay, that is interactive. And this one is a 6 idle. Probably you want to use SPX. So that is something. Before you submit the job, you probably want to type in this command to find out how many nodes is idle. Okay. What else? Here. Also, you probably want to know what is the maximum hours. PVC, you can totally maximum around 48 hours. This one only 24. This is a development. Every time you actually only can use 30 minutes. This one is only 24 hours. Probably the PVC is best for a long time project you want to use, but they count 3 service units to charge you. Okay. Okay, this is a long start. How many hours you can maximum run? 48 hours. A100 GPU, that's 40 hours. A large, if you want to large job, this is a good place. Maximum number, you only can run one job. Count you one. Okay, this is a place if you want to train your machine learning. You want to look at here which partition is best for you. We already tried this command ourselves, -u or -me, that is for your status. We already go through this one. Pending, running, complete. This is another way to show the job status. Also, you can run as control to look the very detail to show your job ID and then anything from them. Okay, that's it. Thank you very much. We're totally done and hope you can play yourself, use it as much as possible. Thank you.